Good evening, everybody. Very good evening, dear. So, कैसे हैं आप लोग? How are you all, guys? Yes, how about your studies? I hope it is going extremely well, dear. That's really nice of you. Okay, guys. Come on, fatafat se just share it to all your friends so that they also can join it faster, guys. Isn't it? Don't delay it any longer. Come on, share it to all your friends faster. That's like a good boy, good student, in fact, I would rather say. Yes, जल्दी से बुला लीजिए सबको, isn't it? Faster, guys. Yes, yes. Nice of you. Very good evening, everyone. Anji, welcome to the class, dear. Arpita, welcome to the class, beta. How about your studies, dear? Great. That's really nice of you guys. Come on, guys, don't wait any longer. Just share to all your friends so that they also can join it faster. Yes, guys, without delay. Come on. That's nice of you. Yes. Very good evening, beta. How are you? That's really great, dear. So, कैसे चल रही है पढ़ाई आप सबकी? अच्छी चल रही है? Yes. All geared up to your exam, isn't it? Yeah, I know because of COVID थोड़ा सा slow हो गया है. I agree. But अच्छा है ना? You don't have to like your time is not being wasted. है ना? Transportation का time is all saved. Yes, and all teachers, faculties, educators are there very much, isn't it, on the platform of an academy. So किस चीज का गम है जब हम सब संग हैं? That's nice. Am I audible, dear? Yes, am I audible? Okay, that's nice. Yes, guys. Isn't it a wonderful evening? Very good evening, dear. Abhijit Malik, thank you, beta. Very good evening. Welcome to the class, dear. That's really nice of you all. Govindan, welcome to the class, beta. Good evening. Yes, am I visible now? I am. Yes, I know. How are you, ma'am? Govindan is asking me, how are you, ma'am? But I'm very, very much fine. And yes, even better after seeing you here. People must be wondering, how can I see Govindan? Yes, this is the latest culture to see all your friends around there. They say hi. That is the online, seeing without camera, isn't it? Just we share hi, we wave each other. Okay? You're laughing. That's really nice of you guys. Come on, guys, don't delay any longer. Come on, come on, come on. Share it to all your friends so that they also come and join it. Today, we are going to have a wonderful discussion over boron and, yes, carbon family. It is really going to help you a lot, not only your exam, but of course, NEET point of view, board point of view. So many things are there to be included in order to have the particular reason why to attend this particular lecture, isn't it? Haji, you are look okay. पढ़ाई भी करनी है बेटा. Yes, thank you for the compliment, dear. Come on, guys. All you guys take pen and copy in your hand. Yes, without delay, we are soon going to start with the marvelous class this evening, isn't it? But come on, once again, I would like to tell you, come on, come on, come on, share it to all your friends so that they also can join this marvelous evening with us. in the form of boron. Yes, we are not going to have a party here. Definitely, we'll have some educational party where we will be studying boron and carbon in detail. Trust me, in detail. Okay. So, guys, welcome to you all to your very own Let's Crack NEET UG channel. I am wholeheartedly welcoming you once again on behalf of entire Unacademy platform. Okay, guys. So this is Sharada Alok. I have been teaching chemistry at Renines at Resonance. I'm repeating, at Resonance, guys, which is indeed one of the renowned coaching institute of India. Okay, so I have been there from past 10 years, guys. Now, there must be a question in your mind. Very good evening, dear. There must be a question in your mind by this time that how to get connected to us. Very simple, guys. Just go to Play Store, download the Unacademy Learning app, and just click on to NEET UG option. And then just you'll be having the subscription, on your screen. But before you go for taking the subscription, let me tell you what are the benefit of these plus subscription. First of all, can you see on your screen here, you'll be finding daily live classes. Yes, you'll be getting daily live classes in which you will be straight away taught by the top educators across the nation. There you can ask your all doubts as well. And yes, all those doubts will be, cleared there itself, so that you'll feel much connected not only to the educator but to the topic as well. And here you'll be having live polls. I'm repeating, here you'll be having live polls where in mid of the lecture you'll be asked a particular question, you'll be given some option as well, and after thinking over you'll be given yeah, of course you'll be given a particular time period for that. Very good evening, Alok. Welcome to the class, dear. So here what will happen, you'll be getting a particular time, and in that you have to answer that question, and of course by clicking that correct, you'll be getting a rank, you'll be getting few referral points out of, I mean, you'll be getting a proper rank, and that will be very much shown on the leaderboard. I'm repeating, that will be very much shown on the leaderboard, and that is going to enhance your academic performance, that will boost up your confidence a lot. Okay, guys. So apart from that, here you get daily live tests and quizzes, which are of course going to add, always going to add to your academic performance, isn't it? They will not only give you confidence, but of course they will make you, you're very ensure that how to prepare for the next quiz or next quiz, I mean test. And yes, here we have quizzes as well. No doubt these quizzes are going to enhance your, of course, going to enhance your academic performance, going to boost up your confidence. Apart from that, here you are supposed to get, referral points. I'm repeating, here you get referral points, guys, and out of that points you can buy any of the courses running at an academy platform, yes, of your choice. Okay, isn't it extremely amazing and exciting at the same time? And apart from that, you'll be getting a detailed analysis of your performance as well, like how you have performed, which all topics you could not do better, what all topics you have to emphasize a lot in terms of practicing and all. And yes, guys, here you, apart from that, here you get structured course which is very well designed, precisely designed by the top educators across the nation. And these all, always help you to prepare in a better way, so that just by putting the same level of hard work, or just by increasing up, just a bit more level of hard work, your, every success is very much ensured in your target. So, guys, needless to say, just by taking one subscription, you are eligible to have all these things, isn't it? Now, guys, there is something very, very new which has been recently launched by Unacademy platform, Iconic subscription. Yes, it has been launched by an academy platform, considering that all the students sitting at every corner of the nation are neither, born same nor brought up same. Okay, guys. So here you'll be getting, these are the important features, guys. The one of the most important one is, here you'll be getting the personal coaches. Those personal coaches will be giving you a one-to-one guidance. Okay, guys. Of course they will be giving you one-to-one guidance, out of which your performance is surely going to enhance. Remember, your performance is surely going to enhance, because they'll be sharing a very, very planned preparation strategy also will be given to you. But of course, at the end of the day, you will have to follow that, isn't it? Yes, guys. In addition to that, here you'll be getting a proper in-depth test analysis. And yes, here after that, you'll be going to get a personalized feedback, how to improve, which topic to be left, which topic to be more emphasized, which topic you are good at, which topic you need a lot of practice. Okay, guys, all these things will be shared under this by the personal coach. And apart from that, you'll be shared with a proper time management. Like, you must be having a proper schedule of your own, which you must be not very comfortable with, or you might be comfortable but you might not be getting result at the same time. So everything is well worked on by these personal coaches. And yes, after that, you'll be getting a proper this what to say time management strategy will be shared to you by the personal coach. Selvam is saying hello beta, welcome to the class, dear. So come on, guys. After that, yes, here again you'll be getting study planner. What is that? That these study planner are so precisely designed that they are going to ace your preparation. Yes, with very very customized study plan, and yes, you'll be getting a bi-weekly reviews as well. That is surely going to highlight your progress. Remember, that is surely going to highlight your progress, guys. And yes, again, needless to say that all these, just by taking iconic subscription, will be getting all these, guys. Okay, now come on. You must be having a question in your mind by now, that what is the difference between this plus subscription and iconic one, whether to go for this plus subscription or the iconic one. I am sure, right? So guys, whatever you are supposed to get under plus subscription, you will be getting the same under iconic subscription. But in addition to that, you'll be getting these other additional features of that. That is, here you will be getting personal code, study planner, expert guidelines, and of course an in-depth test analysis here. And yes, by this time, there must be a question how to take the subscription, how much to pay for the subscription. Here it is on the screen. See, guys, if you go for 1 year subscription, you have to simply pay 45,000, which costs you around 3,750 rupees only. I'm repeating, this costs you only 3,750 rupees. And if you go for 2 years subscription, you are supposed to give 61,000. I'm repeating, 61,000, which costs you around only 2,542 rupees per month. Isn't it extremely economical, yet affordable by most of you, isn't it? So don't delay any longer. Just share it to all your near and dear ones whom you know that because of the crisis of money, they might not be able to come up or live up to their dream, or come up forward to prepare for their targeted or professional examination. So just tell them that Unacademy has got them all these courses at a very economical and affordable, and yet very very qualitative education on the online platform. Okay, guys, don't delay any longer. Come on, share it right now, guys. And yes, don't forget to mention this referral code of mine, SA10, guys, SA10, out of which you'll be getting a 10% discount over this prices. Even I'm repeating, you'll be getting a 10% discount over these prices, guys. And yes, there must be a question in your mind कि referral code तो किसी भी मैम का किसी भी सर का डाल दो, बिल्कुल डाल सकते हो, and कोई भी कोर्सेस आप ले सकते हो. That is all very 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 true. I won't be try to be fool कि मेरा ही लो, ऐसा लो वैसा लो. But yes, बेटा, एक request तो कर सकती हूँ that you should take, you should refer this referral code of mine. And yes, what, क्योंकि हर किसी को कुछ ना कुछ बदले में चाहिए होता है. That is for sure. So here also I'm telling you, if you will take, apply this referral code of mine, which is simply very easy to remember, SA10, you'll be getting some extra benefit out of me, that I would be taking a personal care of you. Apart from all these, I'll be answering all your queries, which are very much personal, but yet at the same time should be related to your target, that is NEET 2021, or whatever subscription you are taking on the. But it should be related, of course. It should have an educational query. I hope you are getting what actually I mean by that. So once again, I'm repeating my this referral code is very simple to remember, SA10, guys. Sashwati, welcome to the class, dear. Very good evening. Very, very good evening, dear. Come on, guys. So if you don't want to go for, iconic subscription, the plus subscription is also there. And right from 1 month to 2 years subscription are there on your screen, guys. So what I would suggest you personally, that if you are planning for crash course or something like that, you should think for this. Otherwise, they are not of any use, because at the end of any of these subscription, you are definitely going to feel that, yes, you would have gone for longer duration subscription, isn't it? And now there's no point in going for crash course right now, because we have a lot of time for this 2021 exam, isn't it? So what you should do, you should not think for these three, okay, guys, because there is no point in wasting money. Okay, Because see, if suppose you go for 6 month subscription, and after the end of that 6 month duration you feel that you want to go for 1 year, and you'll be feeling ki, I have already paid 25,600, I have to simply just pay 4 more hundred more, I mean 6,400 more. That won't happen, guys. You'll have to pay this again. Okay, so there is no point in going for these, at least at this present scenario, when we have lot of time is there for the exam, isn't it? So if you're a student of 12 or dropout, better you go for, yes, this 1 year subscription. Remember, guys, if you're a student of 12 or dropper, you should go for this 1 year subscription. Remember, this is not costing you much, hardly 2,250 rupees per month. Okay, guys, and if you're a student of class 11, you should pay 32,400, which cost you, yeah, extremely less. That is simply 1,350 rupees. I'm repeating, it costs you only 1,350 rupees per month, guys. Okay, yes. I know you all, guys, what you are actually thinking. This is extremely economical yet affordable. And yes, I ensure you that here you'll be getting very qualitative education. Don't worry, very quality education will be there. And yes, they are all precisely designed for your target. Okay, guys, so don't worry, don't delay any longer. And yes, you also take, you should, if you have not taken the subscription, come on, take it without delaying. And yes, share it to all your near and dear ones. So at the cost of money, their dream should not be, compromised. Come on, guys. Once again, needless to say that this is my referral code, which is very easy to remember, SC10. So whenever you are planning to take the subscription, please refer this referral code of mine, which is, again, I would like to tell, it is very easy to remember, simply SC10, guys. Now it's time to study, isn't it? It's time to study, for which we are really sitting here. Yes, guys. Come on, guys. All of you just have your pen and copy in your hand. And secondly, guys, all your eyes on the screen. Third, yes, third, please make it like very sure. Just ensure yourself that you are not sitting in somewhere where you are being disturbed by, or yes, not disturbed. So you should not look here and there also. Okay, no one should be there near to you, so that you should not talk to them. You should not involve in any type of, other than study kind of thing. Okay, guys, then only this lecture or any live classes are going to help you. Trust me, any live classes will help you only when you sit in front of the screen without any disturbance. Okay, बस उसी feeling से, उसी लहजे से पढ़ो, as if you are sitting in a classroom. Then trust me, these live classes will help you a lot. Because I generally every day I come across to many student, and they say, मैम वो वाले क्लास अटेंड करा था, उनका किया, आपका किया, इधर किया, उधर किया. बहुत सारे बच्चे से बोलते हैं कि हमारा ध्यान नहीं लग रहा था, दो चार क्वेश्चन तो बहुत अच्छे से मन कर रहा था, फिर उसके बाद ध्यान इधर उधर भटक रहा था. Why does it happen? Because you are not sitting in a room which is lonely. Okay, I know there are many people who might not have a room which is lonely. You just can do one thing. You can ask all your near and dear ones कि बेटा अभी भैया अभी दीदी अभी मम्मी अभी पापा अभी डिस्टर्ब मत करो, मैं अभी पढ़ रहा हूँ. और दिन भर थोड़ी होती है क्लास, कर सकते हैं ना सब. So I hope you all are guys are sitting very quietly with your pen and copy in your hand and all your eyes on the screen. Without delaying, let us start with the very first question of boron and carbon family. I'm repeating, we are going to discuss NCERT. These are the NCERT discussion, guys. Why I'm doing this, let me tell you one reason for that. Day before yesterday, many of the students came up to me, like either through very different WhatsApp media, or through the chat box, or through the personal messages, or phone calls as well. That ma'am, our school examinations are all, so we just want an NCERT discussion over boron and carbon, and a complete discussion. Because like अभी पहले आप chapter पढ़ाओगे, फिर NCERT पढ़ाओगे, तो it will be like a lot of time will be required. So we don't have that much of time. So I decided to do one thing. Just take NCERT textbook. I'll be straight away starting with the question, but yes, I'll be covering all X, Y, Z factors related to that particular question, so that end of the discussion of these NCERT questions, you will be feeling as if you have been taught the entire chapter thoroughly, and there is no problem in solving any of the subjective question or objective one. Either they belong to a board level or school level, yes, or NEET level. Trust me, NEET level as well. Okay, guys, just look at the screen now. Discuss the pattern of variation in oxidation state of carbon to lead. I'm repeating, carbon to lead or boron to thallium. Okay, guys. First of all, let me tell you this. What is the meaning of oxidation state? Suppose any element A is there. Welcome to the class, dear. There is any element, say XYZ element. Let me take you to different pen color. यहाँ पे कौन सा पेन कलर ज्यादा अच्छा रहेगा? ठीक है. Come on, look at the screen, guys. Let me take you to the first question. Haji, what is actually the meaning of oxidation state, guys? Just look at the screen. Suppose this is A, guys, isn't it? It is A. So you can see this element, it is A. Suppose this is simply in its elemental state. Now, suppose this has undergone a reaction, isn't it? This has undergone a reaction with B and converted into AB. It may happen that if it is A is more electronegative than this will be having a negative charge. In that case, rather instead of AB, will be representing this as A, where this will acquire a minus charge. Or if this is less electronegative, I mean, than C, this will be having this way. In that case, this will be acquiring a plus charge. It may be plus 2, plus 3, whatever, on the basis of depend on the type of element. So guys, here there is no charge on this is simply a neutral atom, isn't it? This is simply a neutral atom, and a neutral atom is supposed to have, yes, zero oxidation state, or in elemental state also the atom is supposed to have zero oxidation state. Is this clear? Now just look at this case here. In this case it has acquired -1 oxidation state, whereas in this case this has acquired +1 oxidation state, depending on the nature of this, depending on the nature of B, or depending on the nature of C. That is out of the deal here. What we are interested to know is what is oxidation number. Is that clear? So there is an apparent change, there is an apparent change in the atom A. This apparent change is actually shown in terms of oxidation state. I hope it is clear. So here the oxidation state is 0, here the oxidation state is -1, and here the oxidation state is +1. So actually oxidation state is just, or number is just, the apparent change when an atom undergoes in a reaction. Okay, either from combined to free state, or from free to combined state, or from any one state to any other state. I hope this is clear. If it is clear, guys, give a thumbs up faster. Faster. I need a thumbs up in the chat box, because I should also need some energy whether you are connected to me or not. That's really nice of you all, guys. Come on, look at the board now. Now let us see that of carbon to lead. Okay, carbon family. Let us see carbon family. Somewhere here, let us write down carbon family. You know, carbon family are what? Yes, carbon, then silicon, germanium, isn't it? Tin, and finally it is lead. Okay, guys. And yes, whether you talk about carbon family or boron one, that it is bagged, boron, aluminium, bag G, gallium, 8 I, indium, and T for thallium. Bagged is a brand name for handbags. Yeah. So that is the way you can learn this bagged boron family, isn't it? So just look at this, guys. Now what you have to see here, these are very much p block element. Okay, and here's the general outer electronic configuration for boron family is, needless to say, it is ns2 np1, whereas in case of carbon it is ns2 np2, guys, isn't it? And you know, guys, what happens, these p block element, please look at the board. If you talk about gallium, okay, so gallium is filled just after zinc, isn't it? Indium is filled just after cadmium. Thallium is filled just after mercury, isn't it? Here you fill 3D. Here you fill, yes, you fill what? 4D. Just a sec. What's gone wrong with this? Come on. By that time, you please like the video, and if you are new, come on, subscribe the channel and press the yes bell icon in order to have further notification, guys. And come on, if you have not shared it to your friends, do that right now. Come on, guys, all your eyes on the screen. So here what happens, this is cadmium. Okay, guys, 4D is filled, and here 5D as well as 4F are filled. Is this okay, guys? Is it okay? 4F, okay. Now what happened, guys? You know that the s orbital are smaller, then p are further, p orbitals is further bigger in size, then d, and then f. So bigger the size of orbital, poor the screening or poor the shielding. And poor the shielding means stronger will be the Z effective, isn't it? So what happens in this case? 3D are filled. Here 3D and 4D are there. Here 3D, 4D, 5D and 4F are there. So more the number of F or D orbital, more will be what? More will be Z effective. Okay, guys. And if more will be the Z effective, less will be the size. It is because of this reason, gallium and aluminium are of almost, yes, it is because of this gallium and aluminium are of almost same size, guys. I hope it is clear. Okay, because just after 3D filling, you fill one electron to 4p here, isn't it? In this case, see, there are two d orbitals, so very poor shielding, but very high Z effective, isn't it? But here in this case, what is happening? Even higher Z effective, which is also called as, guys, famous as lanthanide contraction. And I have very well explained what lanthanide contraction are in periodic table. So you can watch my video. For description for the same is given in the description box. I mean, link for the class is given in the description box. You can straight away go there and watch this video, but after this class. Now all your eyes on the screen, guys. So what happened? As you move down, guys, I'm repeating, as you move down gradually, that Z effective keep on increasing. And because of that, this this NS electron gets, because of the Z effective, this NS electron are attracted more towards the nucleus. And this attraction goes on increasing down the group. I'm repeating, this attraction goes on increasing down the group. And as you know, this in this case of lithium lanthanide contraction, just after this, sorry, you will be having nihonium contraction. But we don't talk much about that. We generally talk till thallium only. So just all your eyes on the screen and look at here. So these NS electron are very much reluctant to come out during any reaction as you move down, because as we move down, this NS electron become more attached, more attracted towards the nucleus, and for which there is a very famous term, guys. We call this, because these pair of S electron do not want to react. They are very much reluctant to react, or you can say they are just inert for any reactivity. And as they are in pair, therefore this is called as inert pair effect. I'm repeating, they're called as inert pair effect, guys. And you know what, two important things about this is to be known. First of all, guys, this inert pair effect starts from fourth period onwards. Yes, starts from fourth period onwards. Why beta? पीहू डेली बोल बोल के थक गए, आपको टेलीग्राम आईडी दे दो. पीहू is asking my telegram id. Beta, it is Sharada Alok. I have already told you. And yes, you can find me at the channel Let's Crack NEET Eugene English. Okay, bye. Bye bye, beta. My telegram id I have given you already. Now look at the screen now. Yes. Haji. So first of all, it starts from fourth period. Why fourth period? Because from fourth period only this orbital, d orbital starts getting filled in. I'm repeating, from fourth period onwards, these d orbital starts getting filled up. Okay, guys. नहीं मिल रहा है, okay, don't worry. This evening only you'll get a link for the same in the description box, beta, but after the class. नहीं बेटा, why shall I ignore you? I don't ignore anyone. Come on, guys. Abhi, fatafat, all you guys have your eyes on the screen. So, is that clear? Why does this start from fourth period only? Because d orbitals starts getting filled up from fourth p only, and you know because of d orbital poor shielding is there, size बड़ा है तो. Okay, guys, that is the reason. और जैसे जैसे you move downwards, that is from fourth period to fifth period to sixth period, this becomes even stronger because Z effective or strong aurora due to lanthanide contraction. नहीं नहीं, आज पक्का मैं आपको अपना टेलीग्राम लिंक उसमें डिस्क्रिप्शन बॉक्स में डाल दूंगी, डोंट वरी. पता नहीं आपको क्यों नहीं मिल रहा, बिकॉज आई एम गेटिंग मैसेजेस फ्रॉम मेनी ऑफ द स्टूडेंट. एनीवे गाइस, जस्ट लुक एट दिस. ओके गाइस, दूसरा क्या है, फोर्थ पीरियड से पहले तो ये स्टार्ट होता है, एंड एज यू मूव डाउन दिस बिकम मोर एंड मोर इफेक्टिव. Okay guys, or because of that, you know what happens, if you compare boron and aluminium, they very well show, because they have plus, you know, 3 valence electron, they very well show plus 3 oxidation state. You will find that they always show plus 3 oxidation state, guys. Okay, whereas in this case, you know, tendency to show plus 3 decreases down the group. I'm repeating, tendency to show plus 3 oxidation state decreases down the group, whereas plus 1, I'm repeating, plus 1 oxidation state increases. Therefore, you can say that thallium plus 1 is more stable than thallium 3. Beta, okay, I'll do that. Don't worry, don't worry. जस्ट आप बहुत प्यार से बहुत अच्छे से पूरा लेक्चर देखो. लेक्चर खत्म होने के बाद आई विल डेफिनेटली टॉक टू यू बेटा, डोंट वरी. श्योर, आई प्रॉमिस दैट. नहीं बेटा, बिल्कुल नहीं, बिल्कुल भी नहीं, डोंट एवर थिंक दैट वे. ओके, डोंट वरी. So guys, just look at this screen. So because of the inert pair effect, you can say that gallium 3 plus is more stable. I'm repeating, gallium 3 plus is more stable than indium 3 plus, which is further more stable than thallium. Or you can say thallium plus 1 is more stable than indium plus 1, which is further, yes, plus 1. So in case of gallium, plus 3 is more stable. In case of thallium, plus 1 is more stable, beta. Okay, so guys, just look at the screen. Now in case of carbon, what happens, same, the concept is same here also. It shows inert pair effect, and remember, as you move down the inert pair effect, every explanation is same. So you can see here they generally show plus 4 oxidation state. In fact, carbon and this silicon, they are what, you know, silicon is a metalloid. Okay, so it shows 4 valency, you should say, not plus 4, 4 valency. And whereas this carbon, you all know that it is a non-metal, it always forms covalent bonding. So valency is 4, rather plus 4 नहीं बोल सकते इसके case में. Okay guys, yes, but yeah, whenever it comes out to find out oxidation state, you should call it as plus 4. Now come on guys, as you move down due to inert pair effect, this Ge2 plus, or you can say G4 plus, is more stable than SN4 plus, which is further more stable than PB4 plus, or PB2 plus due to inert pair effect is extremely stable than SN2 plus, which is further stable than Ge2 plus. Is this clear guys? And this is why you also know one thing, there are one type of question arising here, that out of PB4 plus and PB2 plus, which is better? Remember guys, this question has been asked many time in NEET, that which is better act as better oxidizing agent. You all know that oxidizing agent is one which reduces itself or accepts electron, isn't it? You all know that this PB4 plus is not that stable as PB2 plus because of inert pair effect. So this is a very strong tendency guys, this has a very strong tendency to accept one pair of electron, or you can say 2 electron, and get convert to PB2 plus. And yes, if it is accepting that 2 electron, someone will have to lose that 2 electron, and that someone will get oxidized. In that case, you can say that out of Pb4 plus and Pb2 plus, Pb4 plus is a better oxidizing agent. I hope this is really clear to you guys. So the pattern of variation in oxidation state of carbon family or the boron family is very much clear. So you can say that it is inert pair effect which is the main culprit. But remember, this inert pair effect is shown from fourth period downwards. Remember, fourth period downwards. Okay, and as you move down right from 4 to, you just move down to 5 or move down to 6, it goes on increasing. Okay, why fourth period onwards? Because from fourth period only we start filling 3D, okay, or you can say d orbitals. Second thing, why this inert pair effect increases down the group? Because I'm repeating, because the Z effective increases down the group due to lanthanide, or you can say straight away because of the lanthanide contraction. Okay, guys. Now, guys, very, very important thing. I just want to tell you all about it. That there was a question. There was a question in NEET that what there were few statements written down, and there was a question that what is the difference? I'm repeating. What is the main difference or trend of difference of d orbital and that of p orbital down the group? I'm repeating. What is the trend of oxidation state in a group amongst the elements of d orbital and that of p orbital? Remember, guys, as just now you have seen that as you move down route, right, just right from boron to thallium, the oxidation state decreases and the more stable oxidation state is going on decreasing. So you can say as we move down or as we move towards the heavier element amongst p orbitals element, I'm repeating, as you move towards higher element amongst the p block element, okay, what happens to the oxidation state? Lower oxidation state becomes more stable. Okay, so P से poor, P से poor. ओके, तो नीचे जैसे जैसे जाता है वो बड़ा एटॉमिक नंबर तो बड़ा होते जाता है, बट ऑक्सीडेशन स्टेट पुअर होते जाता है, लेस होते जाता है, लेस बिकम्स मोर स्टेबल. सो दिस इज हाउ यू कैन recall. Now, what is the scenario amongst a D block element? See, guys, as you move down, I'm repeating, as you move down, what happens to the oxidation state? As you move down towards the heavier element, oxidation state increases. जैसे नीचे ऑस्मियम तो कितना +8 ऑक्सीडेशन स्टेट तक दिखा देता है, isn't it? So amongst a d orbital, as you move down towards the heavier element or towards higher atomic number, oxidation state, higher oxidation state becomes more stable, isn't it? So आप कैसे याद रखोगे? Yes, d for d orbitals, d से धनी, d से क्या? धनी होना, क्या होना? धनी होना. तो बहुत रिच होता जाता है और ज्यादा ज्यादा ऑक्सीडेशन स्टेट दिखाते जाता है. आप इसको डॉन भी बोल सकते हो. फिर एक डॉन तो क्या कर सकता है? बहुत सारे पिस्टल रख सकता है, बट रखना नहीं है, इसलिए मैं डॉन के एग्जाम्पल नहीं दे रही थी. धनी ज्यादा अच्छा है. एनीवे, आपको जो इजी लगता है आप वो समझ लो. ओके, बट याद रखना है कि amongst d orbital, the trend of oxidation state is as you move down, I'm repeating, as you move towards a heavier element, higher oxidation states becomes more stable, whereas in case of p orbital, as you move towards higher element, lower oxidation states becomes more stable. नीतू चंदेल मैम, आई हैव अ क्वेरी. शी इज आस्किंग, मैम मेरा टेस्ट 10 अक्टूबर को है, कैसे स्टडी करूं, बीमार हूं. शी इज सेइंग मैम प्लीज रिप्लाई करो. बेटा आई एम सो सॉरी कि मैंने आपको लेट रिप्लाई किया, बिकॉज मैं चाह रही थी वो ऑक्सीडेशन स्टेट वाले कंटिन्यूएशन में अच्छे से खत्म हो जाए. ओके, एंड सेकेंडली आप बीमार हो बेटा, तो आई एम रियली रियली सॉरी फॉर दिस कि आप बीमार हो. तो आप इतना ज्यादा लोड मत लो, बट येस आपको कौन से टॉपिक आ रहे हैं, बिकॉज आई कैन हेल्प यू फॉर केमिस्ट्री ऑफ कोर्स. तो आपको केमिस्ट्री में कौन से टॉपिक आ रहे हैं आप इस चैट बॉक्स में मुझे लिख के दे दो, और अपना कॉन्टैक्ट नंबर भी लिख के मुझे दे दो. तो मैं आपको पर्सनली कॉन्टैक्ट कर लूंगी, आपको पर्सनली बता दूंगी कि कैसे कैसे आप एग्जाम के लिए तैयारी कर सकते हो, और जरूरत पड़ी तो आपको मेरे वीडियो के भी जो लिंक है वो देख सकते हो, और भी जरूरत पड़ी तो आई कैन टीच यू ऑन जूम, डोंट वरी. ओके, आई मीन दिस आपको हेल्प कर सकती हूँ, आपके डाउट्स व्हाट्सएप पे तो आपको बता सकती हूँ, आप उसकी टेंशन ना लो. Okay guys, because Unacademy is there to help you all guys. Okay, so we all educators are very much told to take every care of the students. No student because of the COVID will suffer any longer in terms of studies guys, don't worry. नीतू बेटा, नीतू इज सेइंग मैम ऑर्गेनिक. बेटा 10 अक्टूबर को ऑर्गेनिक का कौन सा टॉपिक आ रहा है, मुझे आप चैट बॉक्स में लिखो, तो मैं आप और अपना नंबर दे दूं, क्योंकि बेटा फिर अदरवाइज व्हाट विल हैपन, वी वोंट एबल टू कंटिन्यू दिस लेक्चर. ओके, तो उसमें डिले हो जाएगा, बिकॉज बहुत सारे बच्चे बैठे हुए हैं एंड आई वांट देम टू गेट देयर एवरी मोमेंट ऑफ दिस पर्टिकुलर वीडियो. ओके, सो मैम प्लीज करना हेल्प, थैंक यू सो मच. बिल्कुल बिल्कुल हेल्प करूंगी. यू जस्ट नोट डाउन योर गिव योर नंबर इन द चैट बॉक्स. ओके, आई विल पर्सनली कॉन्टैक्ट यू. एंड यस, आप अपना टॉपिक भी मैसेज कर दो क्या क्या है, तो मेरे पास जो पहले तो पीडीएफ के नोट्स होंगे वो आई विल बी सेंडिंग यू, और जहां पे भी आपको एक्सप्लेनेशन की रिक्वायरमेंट होगी दैट आई विल बी गिविंग यू, डोंट वरी. So guys, all you can see, the next question on your screen is how you can explain the higher stability of BCl3 as compared to TLCl3. See guys, just now we had explained it, isn't it? You know that inert pair effect becomes more prominent. Let me change the pen. Yeah, yes, इस पे कौन सा चलेगा, blue वाला. Just look at the screen now. So as you move amongst down the group of boron family, just now we had seen that due to inert pair effect, the steel plus one oxidation state is more stronger, or you can say more stable than that of plus three. Let me have a sip of tea. Now look at the screen guys. Okay, this is boron family. Is it clear? Come back to where we were. And in case of boron, you now just you know that this boron is very well show that plus three, I mean three valency. So it just make a covalent bond with that of chlorine very well, and therefore this is stable, guys. Okay, but TlCl3 is not stable because of this inert pair effect, because of the inertness to show plus three oxidation state, because those Ns electron, they don't want to come out. Okay, I hope it is clear. Now the very next question on your screen is, why does boron trifluoride behave as Lewis acid? Why does boron trifluoride, this has no point here, boron trifluoride behave as Lewis acid? First of all, let us see the formula of boron trifluoride. Okay guys, and then let us see what Lewis acid mean. Okay, you know that boron trifluoride 2p orbital of 2p orbital of boron make a covalent bond overlap with 2p orbital of fluorine. So 2p, okay, here you can say all 2p and s orbital undergo, yes, 2s and 2p orbital undergo hybridization, and this sp2 of this. Okay guys, there is a overlapping here. Now because of that, you know what happens, the remember this 1s2, 2s2 and 2p1 guys. Okay, so what happens, there are three orbitals in p subshell. So 1s orbital of 2s, I mean 2s का एक ऑर्बिटल और 2p के दो ऑर्बिटल ओवरलैप करके sp2 बनाते हैं, और एक p you can see this is one p which is unhybridized guys. Okay, so all the three p orbital here form a sigma bond with fluorine like this in one plane. So the shape is trigonal planar here, and you can see this unhybridized p orbital on boron. Yes, this is the unhybridized p orbital on boron is just perpendicular. I'm just changing the color. This particular one is perpendicular. एक तो ये empty है बेटा, मैं इसको shade करके दिखा रही हूँ. This is empty p orbital. And yes, perpendicular to the plane, isn't it? To the plane where all these B and all the three F atom. Bilkul Neetu, I will definitely help you, but I have been helping. In fact, I have come up with this boron carbon NCERT discussion because of the demand of all you children only. Therefore, don't delay any longer. Please share it to your friends. If you are new to the channel, don't forget to subscribe and just press the bell icon in order to have further notification. And yes guys, please like it also. मैम इतना मेहनत करी है, दिख रहा है आपके एग्जाम के लिए, isn't it? Okay, please like it and share it to your friends guys. Now look at the screen. So guys, can you see on your screen that MTP orbital is there? Okay. Now coming to the definition of Lewis acid guys. Lewis acid are the species which can accept a lone pair of electron. Is this clear? Now, the species can accept a lone pair in two cases. Neetu is asking, can you give me your contact number, ma'am? Acha. I will definitely share the link in the description box, a telegram link. Don't worry, beta. Okay? Pakka I will help you. Don't worry. So guys, just look at this, which can accept a lone pair of electron. Okay? कौन से accept कर सकते हैं? Either it should have a vacant orbital, यानी its octet, either या तो octet should not be completed. In that case, will we call this as electron deficient species? Isn't it? Or when the octet is not completed means it is having what? Having empty orbital. Is this clear? Or it can have, suppose octet is done. Octet is all completed. Apart from that, it should have empty d orbital. Isn't it? So both the case, it is going to accept a pair of electron and it will act as a Lewis acid. Now with the help of diagram, just look at the screen. It is very well, I have already shown you that this particular orbital which is perpendicular to the plane consisting all the four atoms, that is boron, fluorine, okay, will accept a lone pair of electron. And yes, because of this, it acts as a Lewis acid. And you can see this boron is having only 6 electron, 2 here, here, and here. Okay guys, so this MTP orbital can very well accept a pair of electron, because of which this behave as a Lewis acid. I hope this is clear. Now the next question on your screen, consider the compound BCl3 and CCl4. How will they behave with water? See guys, I have already written down the reaction here. With BCl3, what happens? This get hydrolyzed, okay, and accept a lone pair of electron present on water and forms this, where this BOH whole thrice is nothing but boric acid, a white solid, isn't it? Whereas in this case, there is no reaction. Let me tell you why. Just now you had seen that this boron is having connected to all these Cl by sp2 and here 2p orbital overlap. Okay, all of them are in one plane guys. Now there is still, abhi just now we had seen that there is still an MTP orbital which can accept a lone pair of electron from water, isn't it? Is this clear? Because of that, this can get hydrolyzed. I'm repeating. Because of that, this can get hydrolyzed. But don't worry. I told you I'll give you the number. कोई मतलब नहीं है. आप अभी का lecture तो ध्यान से देखो. Okay, guys. Look at the board, beta. Yeah, definitely. I promise that I will definitely help you. I've been helping so many students so far. I'll be helping you as well. Secondly, guys, if you have not liked the video so far, come on, do that without any delay. Okay, just have your eyes on the screen now. And in there's nothing such happen in case of carbon, guys. All 8 electron octet is there, and you know that as carbon belongs to second period, I'm repeating, this belongs to second period. There is no empty d orbital here. You all know this because they start from third energy level. So all the orbitals are filled here. So it cannot accept any lone pair from water at all. And therefore there is no reaction. But yes, the CCl4 is very well used as a under the name pyrene, which is used to extinguish, I'm repeating, that is used to extinguish fire. What type of fire? In electrical appliances. I'm repeating, fire in electrical appliances. क्योंकि इलेक्ट्रिकल अप्लायंसेस के आग को हम पानी से नहीं बुझा सकते, क्योंकि फिर क्या होगा, बुझाने वाला बुझ जाएगा. Okay, guys. Now look at the screen. Is boric acid a protic acid? First of all, what is the formula of boric acid? अभी देखा था आपने, H3BO3, or it is also written as BOH whole thrice. Okay. Now you know that, yes, you know that the octet of this is not completed. Now next to that is, what is the meaning of a protic acid? See guys, a protic acid is one which can donate proton, isn't it? Okay, which can donate proton. For example, yes guys, if it act as a protic acid, you know what it will have to do? It will have to do one proton to water. In that case, this will be forming this. Okay, guys, hydronium ion. H plus accepted by water forms hydronium ion, which is written as H3O plus. But remember, guys, this is not possible at all. This is not possible because this does not undergo ionization. I'm repeating, this does not undergo ionization. Instead of that, you know what happens? Yes, because of the octet of boron is not completed. I'm repeating, the octet of boron is not completed. What happens, guys? Suppose you just write down this B here. Now there is an empty orbital as we have seen previously on boron. Okay, guys. To that, you know what happens? The lone pair of oxygen here is very well donated to this. I hope it is very clear. Because of that, you know what happened? Because of that, this boron acquires a charge like this, guys. क्योंकि उस पे इलेक्ट्रॉन आ रहा है तो क्या हो जाएगा? That will acquire a negative charge. And yes, this, there will be a bond here like this, and a lone pair of oxygen is given to boron. So what will happen? Yes, there will be a positive charge here, and you all know that oxygen is extremely electron negative, guys. Oxygen is extremely electron negative. So what it does, it will try to, it will try to have this electron and tell this proton to go away. I'm repeating, because it is more electronegative than hydrogen. Welcome to the class, bete. So what will happen is, it will ask this proton to go away and it will take up its electron. I hope this is very clear, guys. In that case, what is going to happen? पहले तीन OH थे, एक OH और हो गया, so you can straight away, and yes, because of that, this positive charge will go away, and yes, this will be denoted as B OH4 minus. Is this clear? And proton तो यहाँ पे है ही. So this is how it will behave, guys. I hope it is very very clear. So you can say that yes, BOH3 is acting as a very weak monobasic Lewis acid, isn't it? Yes, I'm repeating, this act as a weak monobasic Lewis acid. And because of that, guys, as it can behave as an acid, it can react with base like NaOH. I'm repeating, as it can act as acid, it reacts with base like NeOH. I'm repeating, and this forms, you know what? Yes, together this forms, yes, sodium. You can write the complex either this way, because there is a minus charge just now you had seen in this case. So either this way you can write, isn't it? Why is it so? Because in that case you have seen how it is actually getting formed here. So this can be the possibility, guys, which is also written as sodium metaborate. I'm repeating, this is also written as sodium metaborate, and water of course will be produced out of it. So either way you can go ahead, there is no problem. So it is very very clear what protic acid are. Okay, so is boric acid a protic acid? Yes, correct. Okay, guys, can we say that? See, it is, in order to become a protic acid, it has to lose what? Welcome to the class, beta. Okay. Yes, guys, come on, all your eyes on the screen, eyes on the screen. And yes, if you have any question related to the topic, just comment, drop in chat box. ठीक है बेटा, क्योंकि अभी हम सिर्फ पढ़ाई करेंगे, पूरी तरह से पढ़ाई करेंगे, बिल्कुल पढ़ाई करेंगे only. I hope everybody got it. Come on, look at the screen now. So is boric acid a protic acid? You had seen that in order to do that, this has to do this, which it cannot do. So in order to do that, it should donate a proton, which it is not doing so. Okay, guys, come on, let us go ahead. Explain what happens when boric acid is heated. Yes, guys, this is a very very important question. Always remember, carom board khelte hai na, we use a white powder. It is very slippery in nature due to hydrogen bonding. We'll be definitely discussing the structure. So boric acid is that. Many of you might not able to just recognize what boric acid is. So I just want to tell you that wo carom board wala powder is boric acid. Yes, carom board wala powder is boric acid. Okay, so come on, just look at the screen. What happens when boric acid is heated? I'm repeating, when boric acid is heated, what actually happens? So let me tell you, this is boric acid, H3BO3. Okay, this is a white powder which is having antiseptic property as well. आई वॉश करने में यूज होता है गाइस, बहुत बहुत इंपॉर्टेंट कंपाउंड है ये H3BO3. जब आप इसे when you heat it to 370 Kelvin, I'm repeating it, when you heat it to 370 Kelvin, it gives you HBO2 plus water. Guys, this is what boric acid, and just one water molecule has been taken out from this. Therefore this is what metaboric acid. Let me tell you what meta relation to that of the acid. Remember, H3BO3 is an ortho acid. Okay, now, after taking out one water from ortho acid, it forms meta acid of that. Remember, it forms meta acid. So here, out of taking one water molecule out, this boric acid is forming metaboric acid, guys. Okay. After heating that further, further increasing the temperature to 410 Kelvin, we get H2B4O7. Yes, guys, what happens there? Tetraboric acid. Tetraboric acid. These are the different intermediate changes. But finally, what you will be getting after heating it to red hot, as gradually you can see, as the temperature is increasing gradually, what is happening? It is ultimately giving you B2O3, which is boron trioxide. So you can say that on strong heating, it will be giving you what? Yes, this will be giving you B2O3. See guys, whether it is borax or boric acid, question has been asked many a times that what happens when either boric acid or borax are heated. I'll be telling you what what changes happen to borax in the very later question. But please, all your eyes on the screen. What happens to boric acid when it is heated? तो आपको ये याद रखना है. This gives its yes B2O3 boron trioxide has been asked many times, guys. So this is really, really important. Come on, guys. All your eyes on the screen now. Describe the shape of BF3 and BH4. Assign the hybridization of boron in these species. Very, very common question, guys. Yet very, very simple one, isn't it? BF3. Just now you had seen that sp2 hybridization on boron. And yes, if it is sp2, it will be what? Trigonal planar. I hope this is very, very easy now. And yes, of course, there is an empty p orbital perpendicular to the plane in which all the four atoms, three fluorine and one boron atom are present. Okay, guys. Now, what happens in case of BH3? You know that this is a Lewis acid and an H minus, it is having a pair of electron. Now this pair of electron can be easily donated to the empty orbital of the boron and soon it forms BH4 minus. And you know in this case what will happen? The coordination number is 4, steric number is 4, 4 sigma bond it is. Therefore this will be sp3 hybridized and the shape will be very much what, guys? Yes, for that this shape will be tetrahedral like this. I hope this is clear, guys. This way. Yes, all four hydrogen are present like this tetrahedrally. Yes, and of course this will have a minus charge. So this is the hybridization and the difference and the reason for the same. Now look at the next question, right? Reactions to justify amphoteric nature of aluminium. Remember guys, aluminium is a amphoteric metal. You know what amphoteric metals are? Amphoteric metals are one which can react with acid as well as base. See, amphoteric metals are those which can react with acid as well as base. Okay, so you know, apart from aluminium, which all element act as amphoteric, lead, tin, Sb, isn't it? Zinc. Okay, guys. Now look at the screen now. So how does this aluminium act as amphoteric? See, guys, this aluminium, in order to show amphoteric nature, this reacts with acid like H2SO4 and produce what? H2. It reacts with NaOH and produce what? H2. Yes, I'm repeating. And apart from that, this forms NaAlOH4. Yes, minus, which is aqueous, guys. Okay, is this clear? This is aqueous, that is this compound is very well soluble in water. And how to name this kind of a complex, guys? So how to name this? Such compound are started with the name of the obviously the metal which is less electropositive, I mean more electropositive and less electronegative. So sodium. Okay, and then in case of complex, first of all we name the ligand. Of course I'll be covering coordination compound in detail. Very good evening, dear. Very, very good evening, all you guys. Fatafat say, it seems that you have not liked the video so far. Yes, do that and share to all your friends so that they also can be the part of this wonderful evening, this wonderful lecture of mine on, yes, बोरॉन एंड कार्बन फैमिली. एक बार पढ़ा लोगे तो फटाफट काम हो जाएगा. डोंट वरी, एक बार अच्छे से इसको पढ़ लोगे तो आपका काम एग्जाम्स के लिए हो जाएगा. ट्रस्ट मी, बोरॉन कार्बन का, नीट का, एनसीईआरटी का कुछ भी नहीं छूटेगा. इन 2 लेक्चर्स में ये कंप्लीट करूंगी मैं, एक आज और एक कल. एंड ट्रस्ट मी, अगर आप इसको अच्छे से फॉलो करोगे तो आपका कुछ भी नहीं छूटने वाला है गाइस. ट्रस्ट मी. Now look at the screen, guys. So apart from H2 and this will be like you will be getting. So we were talking about the name. So this is what 4. So write tetra. Tetra and OH is named as hydroxo. 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 And this complex is having a negative charge. So aluminium not will be named as aluminium, but it will become aluminate. And you know that aluminium always exists in an oxidation state of 3. So aluminate, and yes, this oxidation state you will be writing in a Roman numeral, remember. और आप ऐसे भी याद रख सकते हो, the total charge on this AOH4 minus is -1. Let the oxidation number of here is x. हालांकि aluminium का fix रहता है, we need not to calculate, but in spite of that I just want to tell you how to calculate that. And OH minus has got -1 charge, so there will be -4 is equal to -1, so x is coming out to be +3. Definitely, I'll be covering you under a separate chapter on coordination chemistry, how to name the complexes, how to know the charges, how to calculate the charges or oxidation state. Don't worry that. Okay, here this question wanted to show you that aluminum is reacting with a base as well as it can react with an acid because it is basically an amphoteric metal in nature. Now guys, look at the screen. What are electron deficient compound? I'm repeating. What are electron deficient compound? Just now we have seen electron deficient compound. So we won't do this any longer. Electron deficient या तो octet complete नहीं है या फिर empty d orbital है so that it can accept electron pair. It is clear. As you know, this boron Cl3, it has got, boron has got only 6 electron. Empty p orbital is there, so it is electron deficient because its octet is not completed. In case of SiCl4, in this case, here empty d orbital is there. Okay guys, आगे बढ़ते हैं. Come on, write the resonating structure of carbonate ion. Can you see this carbonate ion? See, first of all, जब भी आप resonating structure लिखते हो, सबसे पहले तो आप Lewis structure लिखना चाहिए ना, वो तो आना चाहिए पहले. तो what we do, we look for the central atom. तो सबसे पहला central atom will be the one which is having more valency or that will be less electronegative. So out of carbon and oxygen, you know that the electronegativity value of carbon is 2.5 and that of oxygen is 3. So it is less electronegative and has more valency as well. So this will be acting as a, yes, central atom. Other thing, the more electronegative will be reluctantly be the central atom. Okay guys, now though oxygen may be acting as a central atom in some other case where it is acting attached to more electronegative element, don't worry, but here this won't be the central atom. Welcome to the class, Parthiv. Welcome to the class, beta. I hope you all guys are enjoying. पूरा ध्यान screen पे है, but please like the video. If you have not shared it, come on, share it so that by the time I just like to have a sip. फटाफट share कर लो. Thank you. I hope you must have shared it. And those who are watching this for the first time or present on the channel for the first time, don't forget to subscribe it. And yes, don't forget to press the bell icon in order to have all the notification. Okay. I hope you might have done that. Come on, guys, all your eyes on the screen. So can you see carbonate ion? So this is the central atom. Now write all the oxygen. There are 3 oxygen. We'll be simply writing it like this. Okay. Now you know that carbon has got 4 valence electron. Okay. Oxygen is having 6 valence electron. Now the one thing is there, what we have to do is, just a sec, थोड़ा ज़्यादा ही बड़ा हो गया. Just a sec. So what we will be doing, instead of this drawing this electron here, let me take the eraser. Yes, here is the eraser. Okay. Now guys, we'll be drawing this particular electron here. Okay, 6 valence electron. Now you know that this will try to complete its octet like this. Now coming to this oxygen here, you can see there are two negative charges. Okay, so that negative charge will take up by the oxygen. In that case, this will be having six. So already it had. It will accept one more electron because of the negative charge. Moon Kumar, hello beta, welcome to the class. आपका time क्या है? आई कम लाइव डेली एट 2 PM, वो मेरा फिक्स टाइम है। उसके बाद इवनिंग और मॉर्निंग का टाइम के लिए आपको लेट्स क्रैक नीट यूजी इन इंग्लिश चैनल को सब्सक्राइब करना पड़ेगा, बेल आइकन दबाना पड़ेगा। हर दिन का टाइम विल बी अपडेटेड वेरी मच ओवर देयर। ओके बेटा, सो टुमारो आई एम गोइंग टू कम लाइव शार्प एट 8 AM also. Okay guys, now just look at this one. So two electron here, two electron here, and two electron here. So total 7 electrons are there. Same here because of the negative charge. Now this will be completing this. Oxygen will complete it octates like this. This will complete it octet like this. And yes, carbon will be taking one electron from here, one from here, and two from here. So this is how you can see that carbon has formed double bond with this oxygen and there is a negative charge. So the bond can be shown like this. Okay guys, straight away I see generally when you are very much practiced of this particular making this structure or this particular, you need not to do this, but at very initial stage if I'm teaching it, I just wanted to tell you that this practice of drawing the Lewis structure should, you should do very well. Otherwise then only you will able to come to know this structure, remember guys. So there must be a quick, fast and yes, exhaustive practice of this, and I hope most of you have done that. Now, guys, when we talk about resonance, you know what happens? This negative charge, or you can say there is a, just a pi bond also that keeps rotating. सब में भाईचारा चलते रहता है. Resonance is actually, lot of, collaboration, भाईचारा kind of. So what will happen? This negative charge, the lone pair will be shifted here as pi bond, and yes, this will move up here as negative charge. So this is the, suppose this is the first resonating structure, and between any two resonating structure we make this double headed arrow that shows that these structures are in resonance. They keep interchanging between each other, and here the negative charge will be coming on this. There will be a double bond here, and yes, this remains as it is, isn't it? Or this may happen that this come here, this goes back to this one, the very third structure. This is the second one, and this is the third structure, guys, like this, O minus, double bond. Yes, and here O minus. This is the third structure. Yes, guys, and all these structure are actually, we are supposed to draw a resonance hybrid of all these structures, which is going to, explain you all the properties of this particular carbonate ion. So you can see that because of the resonance, there will be a partial double bond here, here, and here. Of course, there is a partial negative charge on all the three oxygen like this. This is actually the resonance hybrid, guys. And remember, more the resonating structure species is having, more stable it is. Because आप ऐसे समझ लो, आपको मान लो कोई एक you have been given a particular task to do, and suppose if four more are there to join your hands to do the same task. In which condition? At one time you are doing the task alone. At the very next moment you are doing the task, together with three more people. In which case your work will become easier. Of course, when three more people are there to share the work equally. I'm repeating, three more people are there to share the work equally. The same thing happens here. More the resonating structure, more stable the structure is. Okay. Now just look at this structure. When one out of the two negatively charged oxygen, one is attached to H. Okay guys, what happens? Suppose out of the two negatively one is attached like this. there is a double bond like this, and the other one is this. See guys, remember this is a single bond. Okay, this particular is a single bond. This will also be a single bond because there is no such resonance over here. But yes, this will be shifting here, this will be moving here. This is the first resonating structure. The second one is like this. Okay, this is the second one. And remember, the resonance hybrid of the two can be written as, there won't be any change here, but this bond will be the partially double bond character like this. And same here, guys, there will be partial negative charge like this. So this is the resonance hybrid. I'm repeating, this particular one is the resonance hybrid beta. I hope this is clear, guys. But remember what type of questions which not given here but has been asked in NEET, guys, many a times, that how many type of CO bond? How many type? Remember how many type of CO bond? CO bond are present. This is CO bond. Better you write it like this. CO bond are present either in carbonate or in HCO3. Remember guys, here only how many type, okay? So in this case guys, in case of this one, remember only one type of CO bond. All these three CO bonds are equivalent. All the three CO bond are equivalent. Why it is happening? Because of the resonance. You can see that all the three bonds are actually of partially double bond character. Is this clear? All the three bonds are of partially double bond character. Whereas in this case, this is simply a single bond, guys. Whereas these two are, yes, these two are partially double bond. So in this case, you can see that two type of double bond are there. Two types of, two type of CO bond are there. I hope it is clear. Two type of CO bond are there, guys. And one of the very, very important thing I just want to tell you guys here is, look at the screen. There is one more question asked many a time. Suppose in case of, just look at this. In case of this, HCO3 minus, the question has been asked that suppose the CO bond, this particular bond is A. Please all your eyes on the screen. This is A and this is B. The bond length, the correct bond length order. I'm repeating, the correct bond length order. Whether A is bigger than, A is bigger than B, or B is bigger than A, or A and B both are equal. Can you tell me the correct bond length? Always remember that bond length. Remember guys, bond length is inversely proportional to bond order. More the bond order, less will be the bond length and vice versa. Neetu Chandel, welcome dear. Welcome to the class. Yes, she's asking what I should study in short time to get good marks, ma'am. First of all, which exam you are talking about? If you are talking about the exam which you are going to have on 10th October, first of all, you should share me with the syllabus of that. Then only we'll be able to decide that, because I know what type of chapters are being more given more weightage and what type of chapters are just given less weightage. On that basis, you should study. And in fact, for any exam, first of all, you should look for the weightage. Okay, guys, for NCERT also the weightage for all the chapter is given very properly. Okay, so I on the very beginning also I have told you what are the weightage for the particular chapter. So from that point of view, you should do. And one more thing, very very important bit of which no one will tell you before. Suppose there are two chapters. I'm repeating, there are two chapters. And if both the chapters are having, say, suppose like if 3% वेटेज और 5%, सपोज दोनों चैप्टर से सेम क्वेश्चन आते हैं, 4 4 नंबर का दोनों को वेटेज है सपोज, बट इन वन चैप्टर इफ लॉट ऑफ न्यूमेरिकल आर देयर आर मेनी चैप्टर इन केमिस्ट्री वेयर एक चैप्टर को पूरा करने में पसीने आ जाते हैं. I'm very sure this happens. At the same time, there are many chapters कि फटाफट वो chapters हो जाता है, but weightage equal है. So in order to ensure your every success, you should look for those chapter first, which are very easy to complete, which are very easy to click on as well with the options, which are very less, time taking to solve at the time of exam, which takes your very less time. इसीलिए तो I just want to tell you कि इनऑर्गेनिक बहुत अच्छा फटाफट कर डालो, टाइम भी कम लगता है. वी विल बी कवरिंग ऑल दैट, डोंट वरी. But these chapters they take very less time of yours. But what you have to do, whenever you are studying, there should not be any disturbance. There should be a study. आप 1 घंटे के लिए पढ़ो, thoroughly पढ़ो. 1.5 घंटे के लिए पढ़ो, थोड़ो. आधा घंटा भी पढ़ो, just give all your mind to that only. In fact, वो कोई भी सब्जेक्ट पढ़ रहे हो तो आपको ये कंसंट्रेशन तो करना ही पड़ता है. But what I want to tell you is ये चीजें जो है कम टाइम में आपको, और एग्जाम टाइम में भी बस आता है तो फटाफट 1 सेकंड 2 सेकंड में क्लिक करना है, टाइम भी बच गया. अब वो टाइम फिर न्यूमेरिकल को सॉल्व करने में लगा सकते हो, वो टाइम किसी और ऐसे क्वेश्चन को सॉल्व, ट्रिकी क्वेश्चन को सॉल्व करने में लगा सकते हो. डोंट यू थिंक सो? Yes. So these are the strategies which we actually need to work on, and here only the educator is going to help you for that. And yes, if you have to follow those suggestions as well, then only it will work out. I told you, Neetu, just now I'm telling this only, beta. I hope you might have got help for that. If you all guys are getting help by this discussion, okay, of mine, just give this in the chat box. Come on, guys, look at the screen. We were discussing the bond length. So here you know that B has more bond order. So therefore, the bond length of B will be less and that of A will be more. So the correct option is this one. Now guys, all your eyes on the screen, just look at the screen. What is the state of hybridization of carbon in carb CO3 2 minus? Just now you had seen that there was a double bond over here. Here single bond, here also single bond. So in total, how many sigma bond are there? Always remember guys, if carbon has 4 sigma bond, if carbon has 4 sigma bond, it will be sp3 hybridization. First condition. Now, second condition, if carbon is having 3, sigma bond, it is sp2. Third is, if carbon is having 2 sigma, I'm repeating 2 sigma, and the rest will be pi, it should be sp. Here in case, just look at this. This is sigma and this is sigma. Rest 2 are pi. So this is sp hybridization. In this case, if it is like this is sigma, sigma and sigma. This particular one is pi. And yes, if all of them, all the 4 bonds of carbon are single, that is sigma, it is sp3. I hope it is clear. So guys, here there are 3 sigma bonds. So hybridization has to be what? sp2. In case of diamond, guys, you know what happens in case of diamond? Guys, each carbon is further attached to 4 more carbon, and those 4 more carbon are further attached to 4 more, and so on. So you can say that there is a strong network of carbon-carbon covalent bond. And remember the bond dissociation energy of this carbon is very, very high, guys. Because of this, guys, diamond, this particular allotrope of diamond is very, very hard. Thank you, beta. Thank you, Neetu. This diamond is very, very hard. पता है diamond बहुत बहुत hard होता है बेटा. Diamond बहुत hard होता है. आपने have you watched that movie Bang Bang? In which the villain asked Katerina that just try to use that diamond to break something. then the diamond was broken. So Katrina was saying, see, this is the real diamond, you just broke this. The other person said, had it been the real diamond, repeating, had it been the real diamond, the other thing would have been broken down, because if a real diamond is there, it is not going to break down easily. It's not at all going to break down, because this is the hardest substance. I'm repeating, diamond is the hardest natural substance so far on the planet. Okay, so guys, and that is possible because of the strong network of carbon carbon covalent bond. Now, because of this only, it is a very good conductor of heat, guys, but at the same time, it does not conduct electricity at all. Whereas in case of graphite, guys, each carbon is attached to three more carbon in the same layer, and there is a free electron like this below every carbon atom, guys. So these type of layer are present, and that particular planar layer is called as graphene sheet. And because of these electron below the every carbon atom, graphite are good conductor of electricity, guys. Now we have to answer the hybridization. So you can see that there are three sigma bonds. So sp2 hybridization here. And as there are four sigma bond, so sp3 hybridization here, guys. I hope this is clear, guys. Come on, look at the board. Explain the difference between the properties of graphite and diamond on the basis of structure. Just now we had done, so let us go away. Now the next question on your screen, rationalize the given statement and give chemical reactions. Rationalize the given statement and give chemical reactions. Lead chloride react with Cl2 to give PbCl4. Just now we had seen, guys, just now we had seen that Pb4 plus, yes, is less stable than Pb2 plus. Then how come this PbCl2 is converted into PbCl4 in presence of Cl2? How is that happening? Okay, guys. Let me tell you the reason for that. Here it is in plus 2 oxidation state. And on reaction with Cl2, guys, this is forming PbCl4. Remember, the Cl2 is a very good oxidizing agent. And this ensures, yes, this ensures this further oxidation of Pb right from plus 2 to plus 4 oxidation state. Now look at this particular one. Lead 4 chloride is highly unstable towards heat. Lead 4 chloride. This is very, very simple to explain, isn't it? You all know that PbCl4, lead 4 chloride, this exists as plus 4 oxidation state. Okay, guys. When you heat it, this tends to convert into PbCl2 and Cl2. This is very, very simple to remember because of the inert pair effect. You all guys knows that plus 4 oxidation state is less stable, but plus 2 is more stable. So this prefers to convert into plus 2 oxidation state just by heating, isn't it? Now the next one, lead is known not to form an iodide. Is it? Yes, PbI4 already, guys. PbI4, Pb has to be in what oxidation state? Yes, plus 4 oxidation state. Okay, and you guys all knows that iodide is in this, and we have already discussed it many a time. This I minus 1, I minus 1. Okay, guys, is very, very, very reducing. It's very good reducing agent, so itself preferred to be converted into I2, guys, isn't it? So there won't be any I minus, so there won't be any formation of PbI4. Secondly, being a very good reducing agent, guys, being a very good reducing agent, this prefers to convert this back into the most stable oxidation state, that is Pb2 plus, and that is the reason lead is not known in the form of PbI4. Come on, guys. Yes, I'm very happy that you all guys are studying with all your energy out there on the screen. That's very nice of you guys. Okay, come on, guys. Come on, all your eyes on the screen. We have still few more questions to discuss. Now, the next question on your screen is suggest reasons why the BF bond length in BF3 and BF4 differ. I'm repeating, suggest reasons why the BF bond length in BF3 and BF4 minus differ. This has been a question asked many a times in board, and really few times, yes, few times in NEET as well. Okay, guys, and it may come. This is very, very important. And yes, guys, this is not only belonging to this particular chapter, but it is a very, very important question of chemical bonding as well, isn't it? You guys must be thinking कि भाई inorganic में तो बहुत भाईचारा है बेटा, सब में है. Chemistry मतलब chemistry, विष से ना Yes, you share a very nice chemistry. So come on, guys, you also prove it that we do share a wonderful chemistry in terms of your studies. And yes, you all guys have to excel in your exam. But before that, all your eyes on the screen. And yes, if you have not liked the video, come on, do that without any delay. Okay. And if you have not shared it to all your friends, please do that so that they also can be benefited out of it. And yes, one of the very important one, if you're new to the screen, I mean new to the channel, don't forget to subscribe it. And yes, don't forget to press the bell icon in order to have all further notification. Now the next question on your screen, let us discuss that. Why the BF bond length in BF3? This is 130 pm is for, it's not pm for time, it is for picometer. That is the length of, I mean unit of length, 10 raised to the power minus 2 minus 12 meter is equal to 1 picometer, guys. Now look at the I mean screen. So here the PF3, the bond length is only 130 picometer, whereas in that of BF4 minus it is 143 picometer. See, let us discuss this first of all. BF3 is there, guys. We have already seen in today's video that this is sp2 hybridized and 1p orbital remains empty here, perpendicular to the plane. This one is an empty p orbital, guys. Empty p orbital. Okay. And yes, these are having what? Lone pairs on them. Here as well. Now, now what happens? These fluorine, all the lone pairs, they are present where? Yes, 2p orbital. This is also 2p. The size is same. So what happens, guys? There is a wonderful back bonding from any one of the fluorine at a time. I'm repeating, there is a wonderful back bonding. You know, this back bonding takes place from filled orbital to empty orbital. And remember, because of that, there is a double bond generated over here between these two, that is boron and fluorine. Okay. And yes, these all the fluorine one by one keep doing so. Like this. Please have a look at the screen. Now you can say that structure 1, 2 and 3 are in resonance with each other. And because of that, we find a resonating structure like this. Is this clear, beta? Hello, everyone. Welcome to the class. Still lot many things to be learned. Don't worry, beta. Now look at the screen. No problem. You can see the recorded video of today. But अभी तो जो बचा कुचा है वो attend करो. Yes, guys. So because of that, you can see that there is a partial double bond. Yes, guys. And due to that, the bond length of partial double bond is less, yes, less than that of the single one. Whereas, guys, in case of BF4 minus, see what happens, that empty orbital, this particular empty orbital, even F minus gives away its electron to this. And yes, this boron atom is very much surrounded by 4 fluorine like this. There is no empty orbital at all. And yes, there is 4 steric numbers. So the hybridization here is sp3. Okay, guys, and all of them are simply sigma or the single bond, you can say. And you know very well that the bond length and bond order, I'm repeating, the bond length and bond order are inversely proportional, guys. So this particular one is having, yes, more bond order, therefore less bond length. And here the bond order is only one. Okay, so bond length will be more. Now the next question, guys. If BCl, one more thing which I think you must know about it. See, guys, because of this particular property of back bonding, I'm repeating, because of this particular property of back bonding, BF3, though we say that it is, acts as a Lewis acid, the tendency to act as a Lewis acid is very, very weak. You can say that out of BF3, BCl3, BBr3, and Bi3, this Lewis acid property, yes, this is a very weak Lewis acid, whereas Bi3 is a very strong Lewis acid. Why it happens, guys? Because in this case, here you can see that is 2p 2p overlapping. I'm repeating, that is 2p 2p overlapping, beta. Just a sec. There is a 2p 2p overlapping, whereas in this case it is 2p 3p overlapping. Here it is 2p 4p overlapping. Here it is 2p 5p. So 5p of iodine and 2p of boron overlaps, 4p of bromine and 2p of boron, here 3p of chlorine and 2p, here 2p 2p, that is already clear. So guys, the difference in the p orbital gradually goes on increasing, and you know that, as remember, as the difference between the size of overlapping orbital goes on increasing, extent of overlapping goes on decreasing, guys. It is very very simple. दो चीज, एक इतना छोटा है एक बहुत बड़ा है, तो fit कैसे होगा? Okay, so here also 2p orbital is this much in size, whereas 5p orbital is this much bigger. The overlapping will not be that much, and because of that the back bonding is not so efficient enough here in that case. Therefore, जब इधर से पेट नहीं भरा तो भैया कोई और इलेक्ट्रॉन दो. Therefore it acts as a Lewis acid, because yes, because the back bonding is not that stronger, so its octet is not completed, so it needs more electron to do so. So this question can be asked either in terms of bond length or bond order or the geometry or the shape, isn't it? And of course the reason for that. And yes, in terms of compare the overlapping of 2p, this pp orbital, or it can be asked in terms of just compare as Lewis acid order. I hope it is clear now, guys. Chale. Now the next question on your screen is, if BCl bond has a dipole moment, explain why BCl3 molecule has zero dipole moment. Let us see first of all the BCl3 molecule as a whole. It is very much planar, guys, with sp2 hybridization and p orbital of Cl sigma bond. It is a planar one, isn't it? And you guys know that boron, the electronegativity value of boron is 2. मैंने बताया था bi means what? 2. बोलते ना binary compound, a compound which constitutes of two elements. Okay, so आप याद रख लो, B for boron. Very good evening बेटा. मधु, wonderful, welcome to the class. बहुत पढ़ाई कर रहे हो? Okay, चलिए, look at the screen, guys. So boron is bi, guys. 2 मतलब क्या? Bi. ऐसे याद रखना है आपको. And that of chlorine is, yes, it is 3.2. So the difference between the two, the difference in electronegativity is 1.2. So the bond has to be what? Polar covalent bond. Okay, guys. So every bond is, because this is more electronegative, and so that bond moment will be shown this way, this side. I hope it is clear. Now guys, always remember that bond moment are added in vector form. Okay, so the resultant of these two bond moment will be in this direction, guys. And yes, these two are just equal and opposite. This and this cancels out each other. So as a whole, the dipole moment is what? Zero. Okay. Now coming to this, aluminium trifluoride is insoluble in anhydrous HF but dissolves when? Okay, no worries, this will need lot many things, no problem, we can do this. But before that, guys, aluminium trifluoride is insoluble in anhydrous HF but dissolves when NaF is added. It precipitates out of the resulting solution when gaseous BF3 is bubbled through. Give reason. बहुत अच्छा वाला question है guys. Come on, yes, all your eyes on the screen fast. Okay, guys, aluminium trifluoride. First of all, you tell me what is the structure of aluminium trifluoride? Yes, it is AlF3 beta. Okay. And you know that HF is what, guys? HF is a weak acid and NaF is a salt of that acid, isn't it? So just look at the screen. So what happens? HF जो है anhydrous, it is a covalent compound. So what happened, guys? This NaF and AlF3, isn't it? Does what, guys? Three of that together combine and form this complex Na3AlF6. Remember, it forms Na3AlF6. Okay, guys, sodium hexa, yes, fluoroaluminate 3. Just now I told you how to name that. Is this clear, guys? Now what will happen? Yes, because of smaller size and high electronegativity. Okay, guys, boron has high tendency to form complex with aluminium, isn't it? Therefore, when BF3 is added to the above solution, AlF3 gets precipitated. Okay, guys, how come? Let us see. Suppose you are adding BF3 here. What will happen, guys? It will be forming 3NaBF4 plus AlF3 solid. That means this will get precipitated out, and this particular one is a soluble complex. Remember, this is a soluble complex. And what? How to name this? Sodium, yes, tetrafluoroborate 3. Why it is happening? Because BF3, yes guys, it is small in size, high electronegativity. It has much higher tendency to form complexes than aluminium. Okay. Whereas this HF is a covalent compound and has a strong hydrogen bond like this. This is HF. We always represent this by this way. There is strong hydrogen bond because why it is strong hydrogen bond? Because chlorine is most electronegative element of, yes, periodic table, guys. So therefore it does not give F ions and hence AlF3 does not dissolve in HF. Remember, as it is very strongly hydrogen bonded, so it does not donate its F minus to AlF3 in order to, because that is the reason it does not dissolve in HF. Okay, guys, whereas you just now have seen that yes, KF being an ionic compound contains F ion and hence combines with, yes, KF or NAF, you can take any of the that and hence it combines with, yes, it combines with AlF3 to form the soluble complex. This particular complex is very much soluble, guys. I'm repeating, this particular complex is soluble again here. Okay, I hope this is very clear, guys. It is yet again extremely important question. So guys, I hope you must have understood what has been taught to you today in today's class. Okay, so it's time to say bye for now, guys. But yes, before I say bye to you, I just want to tell you that yes, whenever you are planning to take subscription, yes, please use this referral code of mine, which is simply SA10 and very easy to remember, guys. SA10. And yes, if you are new to the channel, don't forget to subscribe it. And yes, don't forget to press the bell icon in order to have any notification without, yes, getting missed. And one more thing, guys, one more thing. This particular thing is very, very important. First of all, as per your requirement, I have got, the revision series, you can say, or explanation series in terms of NCERT exercise, so that you, at the same time, you are preparing for NEET, the very same time, you can prepare for your school exam as well. Because most of you are asking, ma'am, how to prepare, because you have been, though it is COVID, you're not going to school, but all exams are not having COVID. They are very much there. So you have to appear in that. So yes, tomorrow at sharp at 8 a.m. I'm coming, with the same S block discussion, boron carbon. So such type of, NCRT exercise, the whole week I'll keep on discussing. Don't worry. So just in order to have further notification that when is which topics class, don't forget to press the bell icon. Okay, guys. And yes, once again, whether you are going to take plus subscription, or you are planning to take iconic subscription, don't forget to press this referral code of mine, which is SA10. Very simple to remember. No doubt after this you'll be getting 10% discount, and if you apply any other referral code, then also you'll be getting the same discount. But the very difference is, here I'll be taking a personal care of you. Remember, I'll be taking a personal care of you guys. And yes, you must watch all my videos on periodic table, okay guys, or haloalkane and haloarine. The link for the same is there in the description box, guys. Okay, so see you then. See you soon in very next video of mine. Till then, bye bye, guys. So happy studies to you all. And yes, yes, don't forget to subscribe it if you are new to the channel, and don't forget to like to the video. Okay beta, just like the video, or acha lage to please don't forget to comment.